All right, you guys, I'm going to go through the Unit 7 review. I'm going to do separate videos, so I'm just going to be doing topic 7.1 in this video. All right, so I'm going to go ahead and get started. So 7.1 was all about the graphs of quadratic functions and their attributes, like their domain, their range, their axis of symmetry, their vertex, all that good stuff. All right, so the first one says, given the equation, identify the information. They also, of course, want us clearly to fill in a table and the graph. I'm going to use Desmos for this, right, because it's going to give me a great visual and I can just graph it from there. They do want me to fill in the table, and I can get a table from Desmos. So I'm going to go put this function in. So x squared, I go into Desmos, so y equals x squared plus 10x plus 21. All right, so there is the graph. I'm going to go find the major points. Okay, I'm going to kind of make note of those. Right, so -7, right, and -3, and -5, -4. Okay. That's not really, that is 3 points, but my table wants 5. So I am going to go see the little gear in the top of the left side. I'm going to tap on the gear, and then I can hit the table, and it's going to give me a table of values for that function. Let's see. I guess I can use some of those. Those are really big numbers, though. I'm just going to use some of those smaller ones, right? So I'm going to use -1, which is 12. We'll see. And then I'll use the, seems kind of silly to use the 0. And then I'll use the -2, which is 5. Just the smaller ones at the top, because I already have 3 points. Okay, so I'm going to go back to my question right here. I'm going to go ahead and plot all those points that I just found, right? So -7, 0. Sadly, our graph does not go that far, but that's okay. You can go off the graph a little bit. It's not going to kill us. And -3. All right. And then our vertex was at -5, -4. Right. And then we had those other points, -1, 12, and -2, 5. I'm just going to plot that one. Right. So yeah, because obviously all the other points are off of our graph there. I'm going to go ahead and write in some of these, though. I'm going to type in the -7, 0. I'm going to try to go in like numerical order from left to right. And then we had the -5, -4, which was our vertex. And then the -3, 0. And then the table from Desmos told me -2, 5, and -1, 12 were also some points. Obviously 12 is way up there, so I can't fit that on my graph. And then I'm going to draw the best parabola I can. I'm hoping Notability makes that nice and pretty for me. Uh-oh. And it's not gonna. Let's see if I can. Oh my goodness, that's so not. What is it doing? It is so, okay, I'm going to clear that. That is so not doing what I want it to. I'll just do that by hand. All right, so here we go. Just do the best parabola you got. Make sure it's U-shaped and not V-shaped. All right, we don't want a sharp V going on. All right, good enough. I'll let that go. All right, so then they want us to label all of the attributes of this graph. So clearly the vertex, remember the vertex is the highest or lowest point of the parabola, and that is clearly -5, -4. The axis of symmetry is that imaginary vertical line that splits your parabola into two symmetrical parts. So that's going to be x equals -5. Our next question, is it a max or a min? Well, our vertex is the lowest, and it's talking about the vertex, right? So our vertex is definitely the lowest part of this graph. So he is a minimum, right? He is the most minimum value that this graph takes on. And over here, when it asks, we've seen this before, when it asks for the min or the max value, it's asking for the y value at that vertex point. So our max value is 4. Our min value is 4. Sorry. All right. And if you want to circle minimum again, you certainly can, right? Okay. I'm going to draw an arrow. So all these are just all linked together, right? All right, the zeros are, of course, the solutions, aka the x-intercepts. Remember, zeros, roots, solutions, x-intercepts. I'm going to write all those down over here. Roots, solutions, x-intercepts, right? These are all synonyms of zeros, right? They all mean the same thing. All right, so our zeros are -7, 0, and -3, 0. All right, I'm kind of trying to keep this color coded here. Now our y-intercept, right? Our y-intercept is way up here, right? And if you need to, you can go to your, to Desmos, right? Our y-intercept is clearly in our table. See where it says 0, 21? Or we can actually go maneuver our screen in Desmos and also see that it's 21. Or, let me give you a third option. Hold on, let me just go ahead and write it, 0, 21. When your function is written in standard form, which ours is, then the c value is the y-intercept, right? Because he's the constant hanging off the end, kind of like the y equals mx plus b, right? Like the b in y equals mx plus b, right? So the c value hanging off the end is your constant, is your y-intercept. So that's literally 3 different ways: table, graph, c value. 3 different ways you can identify your y-intercept. All right, and then we have our domain and range, right? Clearly our domain is all real numbers because there are no walls, keeping it from going left or right forever. But then we have our range, which is not all real numbers because there is a wall right here. And I just realized, now that I just said that I accidentally forgot to put the negative on this 4. Sorry about that. Up here at the min-max value. So sorry. So the minimum value is -4, not 4. I don't know why I didn't put the negative. So our range is that y is everything greater than or equal to -4. Okay, so I tried to kind of color code all of that, so hopefully you can follow all of those parts. You guys did really awesome with all this in class though, so I'm sure you're fine. All right, number 2, instead of giving you the equation or the graph, right, they gave you the table of values. Now, if you want to, we know that anytime we see a table, we can put that in Desmos. So I'm going to go ahead and do that just in case you want to. You certainly don't have to. That is not a requirement to do this problem, but I'm going to do it just in case it helps any of you guys out. So here we go. I'm going to type in my table. And notice it's plotting my little dots for me as I go. And then if you want to actually see the parabola drawn, then you can go tell it to run a quadratic regression, and it's going to draw you the parabola. And of course, it's passing perfectly through these quadratic points, right? So there's the parabola that we're talking about here. So you'll notice we can identify all of these awesome attributes about our graph just by being given the table. Okay, now do you have to make this graph? Absolutely not, but it's so awesome to have a visual for yourself so you don't make a silly mistake. All right, I'm gonna go back here and I'm gonna talk about how to find all these answers without needing the graph, but again, that's an option if you want it. All right, so remember the vertex is the very middle of the graph. So you're looking for the y value, right? That is the center of, hold on, let me change colors, sorry. Notice the reflective quality around the -4, right? He's surrounded by -3s, and then the -3s are surrounded by 0s, right? So that reflective quality tells me that this is the middle point because everybody around him is a reflected y value, okay? So that gives us our vertex of -1, 4. Which of course means our axis of symmetry is x equals -1 because we know it has to go through the vertex and the vertex has an x value of -1. Excuse me. Now, is it a min or a max? Well, that's when I need to go back up here to my table and ask myself, if my y value is -4, what are all the y values doing to the left and right of it? Are they getting bigger or smaller? Or in turn, you can ask yourself, is -4 the highest or the lowest value of all the y's? And clearly, -4 is the lowest y value that we see in this table. So that means he is the minimum. He's at the bottom of the graph, which again, I already typed this into Desmos, and I can see it's an upward-facing parabola, so I definitely know it's a minimum, and that minimum will have a y value of -4. All right, then it wants our zeros, which means the solutions, right? So that means we're looking for when y is 0, right? So this guy is a solution, and this guy is a solution, right? And of course, I can confirm that in Desmos. That's exactly where we saw it crossing the x-axis. And then, of course, next we have the y-intercept. Well, that's when x is equal to 0. Right, so that's 0, -3. All right, and then of course our domain is all real numbers. And our range, remember this is an upward facing parabola. I'm just gonna draw a little sketch down here. This is an upward facing parabola where the vertex point is -1, -4. So that is the wall, right? -4 is our lowest y value, right, that we're going to hit. So our range is y is everything greater than or equal to -4, which again, if you're better with a visual, then you can totally come back here and see, oh yeah, my graph is everything greater than or equal to -4. All right. Let's go take a peek at talking more about solutions. Okay, so on these problems, they're asking just by looking at the graph, how many solutions are there and what are they? All right, so on this first graph, right, remember solutions are the x-intercepts, right? So this one has one x-intercept, which means it has one solution. Okay, now remember, I'm gonna put, and you don't have to do this if you don't want to, right? But remember, that means it's a double root. Right? I'm getting the same solution twice because every quadratic does have two solutions, right? We just happen to be getting this solution 2 times. All right, and what is that solution? Well, it looks like I'm exactly between -2 and -3, so it looks like -2.5. And again, if I was to solve this by factoring or the quadratic formula, I would be getting x equals -2.5 and then x equals -2.5 again, right? Hence only the one solution. All right, on this one, how many solutions? Well, clearly, right, it's crossing the x-axis here at 1 and then crossing again here at 4. So he has 2 solutions, as all quadratics do, and his solutions are 1, 0, and 4, 0. All right, I really love this next question. It says, if a catapult, right, which is like a launching device, launches from the origin and has a maximum height of 5.2, 6.3, what is the coordinate of where it would land? I love this question. It's not difficult by any means, but it does test your knowledge about the symmetry of a parabola. So I'm just going to kind of draw what's happening here. So here's the origin, right, in the corner. I'm just drawing quadrant 1. And then we're launching something up and then down, right? So this is, let me just try to get a nicer parabola here. Oh, why isn't it making? There we go. Okay. So I'm launching something from the origin. It's going up, right? It's hitting its maximum right here, which is 5.2, 6.3, which again, remember, I'm going to kind of, that means this mark is the 5.2, right? And this height is the 6.3, right? Just making sure we know that our x's and y's and where they are. They want to know what is the coordinate where it would land, right? So we're looking for this. Well, if it started at the origin and it went up to the vertex and then back down, I know that this guy is his axis of symmetry. So he went, we'll assume it's like seconds, right? So the object traveled 5.2 seconds, or whatever time it is, before it hit the highest peak. And because of the symmetry of a parabola, that means it must have traveled another 5.2 seconds to then hit the ground, right? So I know that the question mark is going to be 10.4. Right? Because I'm just literally doubling 5.2, because if it went 5.2 on this side, it went another 5.2 on this side, because it has to be a mirror image of itself. It did ask for the coordinate. Well, of course, when it hits the ground, the y coordinate is 0. Right? And that would be our answer. Okay, 10.4, comma 0. All right, we got a couple more. All right, number 5, they give you 4 different functions, right? And you are more than welcome to type every single one of these into Desmos to help you answer this question. I am not going to do that because we already had the discussion about when a quadratic is written in standard form. It only works for standard form, that C value is the y-intercept. We just talked about that on number 1. So that means I automatically know, excuse me, I automatically know all of the y-intercepts of these graphs, okay? The other thing I know about these graphs without using Desmos, but of course you are more than welcome to do that, is that this whole quadratic is positive, which means he opens up. All right, I'm just going to kind of write that here. Actually, I'm going to draw it next to it. Why not? All right, I know this guy opens up because he's a positive function. I know this guy opens down because he's a negative function. This guy over here, he also opens down because he's negative. And then the positive 2/3 tells me he opens up. All right, so I'm just putting little notes there for myself. Excuse me, sorry. So that's a lot of information, right? Because I know their y-intercepts and I know whether they open up or down. Okay, it says which 2 equations have the same y-intercept? Well, that's pretty easy, right? Since we know that the C values are the y-intercepts, and it looks like this one and this one both have a y-intercept of positive 4. So I'm just going to refer to that as their given names of f of x and j of x. They both have the same y-intercept of 4. Okay, then the question says, which 2 equations have a maximum? Well, I know maximums only occur when the parabolas open down, right? So that means that g of x and h of x would be the only 2 quadratics that have maximum values in this case. And then our last question says, which 2 equations do not cross the x-axis? Now, this is one you might want Desmos for if you're not 100% sure what's happening with these graphs. But the one thing I do notice is that all of these y-intercepts are positive, okay? And so let's reason our way through this, and then I'll go put them in Desmos to prove it in just a second. Do you guys notice on this one that the y-intercept is 4, but it's also opening up? So that means that this, and by the way, all of these graphs don't have b values, so that means they're sitting perfectly on the y-axis, which again, you would totally see if you put this into Desmos. So this guy is sitting at 4 on the y-axis because it doesn't have a bx term in the middle. None of these do, so they're all centered on the y-axis. So he's starting at 4 and then opening up. Well, if that's the case, he's never going to touch the x-axis, right? Because he's above it. Right? Now this one over here, here's my y-axis, right? And here's this. So he's at 7, but he's going down. So even though he's starting pretty high up on the y-axis, he's opening down. So of course he's going to cross the x-axis. Okay. Next one, same thing. He's starting at 5, but again, he's opening down. So he's going to cross the x-axis. I don't know why I put such a, hold on one sec. There we go. I didn't mean to put such a large thing, looked like an axis. And then over here on our last one, right, we have, here's our y-axis, here's the 4 value, right? The x-axis is way down here, right? And he's opening up from 4, so he's never going to cross the x-axis, right? So I know this is going to be f of x and j of x. If that logic confused you in any way, that's okay, right? So we are, if I go into Desmos, let me just show you this really quick. If I type in f of x, I'm just going to put y, if that's cool with everybody. If I type in 3/4 x squared plus 4, I can clearly see again, right? He is starting at 4 and going up from there, so he's never crossing the y-axis, right? Same thing if I were to type in all the other ones. So this is all about giving yourself a visual, so just use Desmos whenever you need to, okay? All righty. Last question for this section. So number 6, the graph of the quadratic function is shown on the grid. Which statement best supports the graph of k? All right, so here we go. It says the first Roman numeral says the x-intercept is at -3, 0. I'm going to zoom in here. Let's see, -3, 0. Yep, that looks like it's true. I'm going to put a little check mark there. All right, the next one says the coordinates of the y-intercept are 0, 9. Well, 0, 9, yeah, that looks true also. And then the last one says the axis of symmetry is x equals -3. Well, here's our axis of symmetry line that is crossing the x-axis at -3. So yeah, I would agree with that one also. So it looks like all 3 of these statements are true. All right. Okay, that concludes topic number 1, attributes of quadratic graphs. Just let me know if you guys have any questions.